We're going to get started. So my name is Andrew, and I'm a software engineer and tech lead for companies like Microsoft, LinkedIn, Snapchat, IBM, BlackBerry in the past. And I will be an instructor for this course, Software Engineering Technical Interview Preparation. And I coach, I do one-on-one mentorships, and I do group coaching for people like for people like you, and I provide assistance and real world interview preparations for full-timers who are seeking jobs in tech and in Silicon Valley. I hope I can be a great assistance for you. And so please sign up for my course. I do software engineering, data analytics, preparations, and technical interview questions. So if you're interested, please sign up for my course, and you can use my referral code Andrew, ANDREW, on https://HiCounselor.com, and then you will get $500 discount when you start paying HiCounselor after you get the job. Remember, with HiCounselor, you don't pay anything upfront. There's zero cost upfront. So once you get the job, that's when you pay a small fraction. So yes, please go to HiCounselor.com and sign up for my course. The referral code is ANDREW, and then I will be your one-on-one and technical preparation coach for getting into companies like Microsoft, LinkedIn, Apple, BlackBerry, where I've all interviewed in the past. So yeah, this course, in this session, we're going to do memoization. So what is memoization? And first of all, we're going to go through some explanation, and then we're going to solve some problems together. I'll give you some time to solve it, and then we'll look at the implementation answer after. So we have done dynamic programming in the past sessions, and most of the DP problems are solved a couple of ways. Number one, tabulation, which is bottoms up, and memoization, which is top down. And one of the easier approaches and methods to solve most problems in dynamic programming is to write the recursive code at first, and then write the bottoms-up tabulation method or top-down memoization of the recursive function. The steps to write the DP solution of top-down approach to typical problems is to compose the recursion code, and then memoize the return value and use it to reduce number of recursive calls. So the first step is going to be write the recursive code. And by the way, memoization makes sure that method does not execute for the same inputs more than once. This is done by keeping the record of results for given inputs. And usually the data structure is Hashmap. Oh, by the way, I encourage you to write this down on a pen and paper instead of Word, Google Docs or anything online, because you actually absorb and learn so much faster and so much more efficiently if you actually write this down. And in my lessons, I don't I don't write a lot, so it's not going to be a lot of writing for you. So make sure you write it down on a pen and paper instead of laptop, because that's the method I used, a pen and paper, and it worked really well when I'm preparing for interviews. So yeah, usually it's done in Hashmap. So again, memoization ensures that method does not execute more than once for the same inputs by storing results in data structure, usually Hashmap, hash table, or array. So there's a couple of ways. There's 1D memoization. And in 1D memoization, the first step is write the recursive code. So for example, if we have method like this, Fibonacci, we have to write the base case, right? And then you write the recursive calls. And then you have the, the driver code. So in this program, the program related to recursion where only one parameter changes its value is shown. So because only one parameter is non-constant, this is going to be a 1D memoization. For example, the Fibonacci series problem to find the nth term in the Fibonacci series. So this is going to be a 1D memoization, and it's going to have an output of 8. So a common, observation is that such implementation does a lot of repeated work. So this will consume a lot of time for finding the nth Fibonacci number if done. So right, if you look at what Fibonacci does, it does 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144. So this is going to be f of n equals f n minus 1 plus f n minus 2. Okay, so how does it look like if we check memo? So let's try to use, memo. So we're gonna, number one, check memo just to observe if we can avoid computing the answer for any given input. And we're gonna save results. So this time I'm gonna use Java. So how does it look like? And then you write the base case. And then you see if we've already calculated this. Oh, this is not Java, by the way. Sorry. And then you memoize. This is where you memoize. Okay, so we've solved the problem together. Actually, sorry, we did an example together, and I want to give you maybe 3 to 4 minutes to try this problem. So, question, and this is for you to think. So, Tribonacci sequence is essentially as such: t of 0 equals 0, t of 1 equals 1, t of 2 equals 1, t of n plus 3 equals t of n plus t of n plus 1 plus t of n plus 2 for n larger than 0. So given n, find value of t of n. So this is the problem. And I want you to think about it for 3 to 4 minutes, and then we'll solve together. Okay, let's try to solve this. So we've seen that, what's going on? Okay, yeah, we've seen that the tree or Fibonacci number is according to the equation, t of n plus 3 is going to be t of n plus 1 plus t of n plus 2 for n larger than 0. Right? So for example, if we have input of 4, the output's going to be 4. Why? That's because t of 3 is going to be 0, 1, 1, 2, which the summation for which is going to be 2, sorry. And then t of 4 is going to be 1, 1, 2, which the summation for which is 4. So that's going to be 4. So how do we write this into an implementation or a solution?
First of all, 3 base cases of 0, 1, and 2, and then do the same as above, like calculating the value for n and putting it into the hash map if it's not already present in the hash map.
Yeah, so there's a couple ways. Number one is the first method is going to be time complexity of O of n and then space complexity of O of 1. So let's try with a solution that will run for loop where the new element is calculated, and then we essentially do new element calculation by calculating adding all previous 3 elements, which is going to be first, second, and third. So let's try to write this down. Here, the first, second, and third are previous 3 elements. So if n is equal to 0 or n is equal to 1, then the Tribonacci number is n itself. And if else, the for loop is going to be executed. That's why we start from 3 instead of 0 or 1. And then if n is equal to true, then the for loop is not executed, and the initial value of the variable third is returned, which is going to be 1, right? So if n is equal to 2, for loop not executed. The initial value of 3 is returned, which is going to be 1. So we just return the last element. So this can actually be, for the simplicity of the code, can be written like this. which is essentially the same algorithm. All right, so let's try another very interesting problem. All right, so you have integer n. You want to find a list of all possible full binary trees with n nodes, okay? And every node of each tree in the answer must have node.value, which is going to be 0. So every element of the answer is the root node of all possible trees. So you can return the final list of trees in any order. So you may return the final list of trees in any order. And by the way, the full binary trees that means binary tree in which every node has exactly 0 or 2 children, okay? So for example, let's say we have something like this, right? Let's say we have something like this where we have input of 7, okay? So we're gonna have 7 nodes. So the n here is gonna be 7. And the output should be something like this. So null just means there's nothing there. There's no node. Whereas 0 means we're gonna there is a node. So that means it's filled up. Okay. And lastly, like this. The output is going to be like this because each of these array within the larger array represents the trees in the solution. You see that here we put 0, 0, 0, null, null, 0, 0, null, null, 0, 0. For the, let's say, second one, we have 0, 0, 0, null, null, 0, 0, 0, 0. We look at this third one, it's going to be all 0 because it's like, you know, it's like well balanced. The fourth one, we have 0, 0, 0, 0, 0, null, null, and then null, yeah, so 0, 0, 0, 0, 0, null, null, sorry, null, 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 and then 0, 0. If you look at the last one, 0, 0, 0, 0, 0, null, null, 0, 0. So this should be your output. So this is a slightly more difficult than the previous problem, but let's look at how we can solve this. And then we'll look at the implementation together. So I'll give you like 4 to 5 minutes. Okay, so let's try to solve this together. So there's many ways. There's intuitively, we think about recursive solution, which is totally correct. And then there is also a way to add cache so we don't repeat and values. And then there's the iterator solution where we literally go through everything. So let's look at a recursive solution and where you recursively find all the possible children of each node at each level. So at every level, you subtract 1 from n because this node counts as a node. So n is given as 1 to 50. And for example, if n is equal to 1, you return a node with no children. For every I, where I is the number of left children, we call all possible FBT I and all possible FBT n minus I for the remaining children on the opposite side. So you iterate through all the possible combinations of children, setting the current nodes left and right and adding it to the result list. So let's take a look. So again, what we did is we recursively find all the possible children of each node at each level. At every level, we subtract 1 from n because this node counts as a node. So if n is equal to 1, we return a node with no children. For every I, where I is the number of left children, we call possible trees I, and possible trees n minus I for the remaining things on the opposite side. Then we iterate through all possible combination of the children, and we set the current nodes left and right, and we add that to the result list. So this is the way we can use recursion to essentially generate this output. So now there is, yes, so I want to give you one more problem to sort of like think about as as we finish the session, and then it's not a homework assignment, but it's something you can think about, and then in the next session, something we can circle back on. So I want to give you guys something to think about after this session, so you can do it on your own. So you can solve the problem on your own, and it's intentionally hard. It's intentionally hard, and I want to, sort of give you something to work on your own. So let's say you have x by y integers. You're given an x by y integers matrix, and you want to return. You want to find the length of the longest increasing path in that matrix. Okay, so from each cell, you're allowed to move in 4 directions: left, right, up, down. You cannot move diagonal. You cannot move outside the boundary. So for example, let's say you have 994 . So the input is going to be like this: the matrix 994, 668, 221. The output is going to be 4 because the longest increasing path is 1, 2, 6, 9, right? 1, 2, 1. Yeah, 1, 2, 6, 9. Okay, so you want to be able to find the longest increasing path in the matrix, and you can only move north, south, east, west. All right, so another example. In this example, the answer is going to be 3, 4, 5, 6, because that's the longest increasing path of the matrix. So I just want to thank you very much for your attention today and participation. Again, if you need assistance with job searching, internship finding, tech positions at companies like Amazon, Microsoft, LinkedIn, Snap, HiCounselor could be a great resource for you. Especially, I can be of great assistance because I've been there when I was looking for jobs. So the payment structure at HiCounselor is income share agreement, where you don't pay anything to HiCounselor until you land a job. So once you land a job, then you pay a small fraction of your first year's salary in 6 monthly installments. So there's nothing upfront payment. The cohort, the next cohort at HiCounselor starts very soon. So if you're interested, please apply on HiCounselor.com, and feel free to use my code Andrew, which is here, ANDRW, and you will get $500 discount when you start paying HiCounselor after landing the job. So I want to just give you a couple of things that I provide. Is number one is technical interview preparation, one-on-one, group coaching, and then career consultation, one-on-one, and then approaching recruiters and LinkedIn properly. So if you're interested in any of these, please reach out to HiCounselor and then let them know that you're interested in any of these four with Andrew, with a referral code Andrew. All right. So so when you get off the call, get off the Zoom, I want you to think about this problem. Given n times m or x times y integers matrix, find the length, the longest increasing path in that matrix. So you can only move in 4 directions: left, right, up, down, and you cannot move diagonally. You can only move within the boundary. So just to give you a hint, before we leave, you can actually do depth first search. You can use depth first search from every cell, meaning you do DFS and then you compare every 4 directions and skip cells that are out of boundary or smaller. And then you get the matrix from every cell's maximum. And then you use matrix comparison between 2 cells, so you don't need visited array. Usually you use visited to mark all the nodes that have been visited, but you don't need this. So the key is to use cache to get the distance, because it's highly possible to revisit the cell. All right, so the hint is to use DFS, and that's how you get the maximum length of increasing sequences. All right, so I want to thank you very much, and I'll see you in the next session.